Hello everybody. Welcome to Creating the Basic Adaptable Game Engine Library, Part 28, Adding Solid Objects to the Game. In the previous video, we learned how to add a few more functions to some of our core classes, the vector class, the rectangle class, and the sprite class, to help us create the ability to simulate solid objects in a game. In this video, we'll learn how to actually use those objects in the Starfish Collector game. So, let's go ahead and open up that development environment. Now first, to remind you of what our game currently looks like, right now there is a turtle and some starfish, and that's about it. Right, so no obstacles, nothing blocking the path of that turtle, but this is about to change. So let's go to the Starfish Collector game class, and let's say I want to add a couple of rocks. So let's do group, I'll call this a rock group, and then within the initialize function, maybe we'll just add a couple of rocks. I don't want to add too many. And so maybe I'll do this before adding the starfish. So we'll add a new rock group. Avoid adding a music pun about rock and roll music here. Let's create a new texture object. In the images folder for this project, I have a bunch of different images which we're going to use for this game. In particular, one of them is called rock. So images/rock.png, we'll go ahead and add that. We'll say int rock count equals maybe 3. If we had too many rocks, the game could become unplayable. Then let's say for int I equals 0, I less than rock count, I plus plus. We're going to create a rock object at some random coordinates. So let's say a sprite called rock is a new sprite. Let's say double x is equal to math.random. And I'm just going to copy the code from below, the one we used to randomize the positions of the starfish, because that's some good code right there. Except wherever there's a reference to starfish, I'll replace that with rock, and the starfish collector, or the starfish texture, excuse me, I'll replace with rock. Cool. And once we have the rock group, this should be rock group here. We have to be sure we add the rock group to the main group for the stage. So group.add rock group. Right? Otherwise, it won't be rendered at all. Let's go ahead and give this a run. We should see 3 randomly placed rocks. And there we go. We've got 1, 2, 3. Now, of course, we haven't added anything about preventing overlap, so this turtle is just free to swim by them as if it's swimming over the rocks. But I'd really like to make these unpassable. So let's go down to the update method, and let's do the following. So we'll add some values to the turtle's position, but then before we get to, let's do this after we check for an overlap between turtle and starfish. For each entity, let's call it entity for now, in the rock groups list, so rock group.getList, and just as before, when we get the list of a group that returns entities, so we need to convert that to a sprite. So sprite rock equals cast to sprite, that entity. And then, let's just say, turtle, we do not want you to overlap with a rock, so turtle, prevent overlap with the rock. Right, so to the user, to the player, it's going to appear as though the rocks are solid. Because if the turtle were to overlap with a rock after changing its position, then this will immediately readjust the position of the turtle before the images are rendered to the screen. And that's why we wanted to put this block of code specifically after we check for input. Okay, with those additions, let's go ahead and run Starfish Collector. All right, there's there's one rock hiding on the starfish. Let's see what we can do, and we can't go through it. Right, so right now I'm holding left, and every frame the turtle is overlapping the rock by maybe a couple of pixels, but the position of the turtle gets readjusted so it can't actually pass through it. So that's fun. One thing which is not fun, it's a good thing these rocks are relatively small, right? And the starfish are a little bit bigger, so I'll always be able to get at those starfish. One thing you always have to be worried about when using random elements in games is you want to make sure your game is still going to be winnable. And that's why I didn't do something like put 30 rocks in the game. Can you imagine what would happen if we put 30 rocks in the game? Well, if you can't imagine, let's just put 30 rocks in the game and see what happens. And so if I go ahead and run the game now, it's going to be very easy to generate a scenario, a no-win scenario. Right? There's so many rocks there, there's going to be some starfish I just can't get to. And like all the starfish that are in here, just no way. You could alleviate this problem a little bit by making sure the starfish do not spawn on top of the rocks. And I'll show you how to do that in just a moment. But even if you make sure those starfish don't overlap with the rocks, you could accidentally get a rock wall which bars your progress from one side of the screen to the other. So procedurally generated content is a tricky topic. It's excellent, you just have to be careful. So to stop the starfish from overlapping with the rocks, well, we could do the following. We could say, right here in the code which generates the starfish, right, we set them to a random position. And then, let's say after we've added all this information, I want to do this after we add the texture as well, because setting the texture also sets the size of the starfish, which we need for boundary checking. We need to maybe create a while group. So let's see. We could do the following. And so logically speaking, we need to check this starfish against the positions of all of the rocks. And if it overlaps even one, we're going to set it a new random position. And this is one of those cases in which a do-while loop will actually work a little bit better than a while loop. Let's start off by creating a Boolean called rock overlap, and we'll set that to false. Maybe it doesn't. In which case, or in every case, we will do something while something else. So what we'll do is we'll check each rock, right? So for each, now we need that method again, each entity in rock group dot get list. Let's go ahead and, oh, that's not right. There we go. We need to cast that to a sprite. So let's say sprite rock equals sprite entity. And then if that rock overlaps the starfish, so if rock.overlaps starfish, in that case, rock overlap will become true. Right? In which case, we're going to need to reset the position of the starfish to something else. So I kind of want to copy this code over here. I can remove this. Right, so let's see. What we'll do is we'll pick new x and y coordinates and move the starfish to that position. We'll check if that rock, if any of the rocks overlap the starfish, in which case we'll set rock overlap to true. And while rock overlap is true, we'll repeat this process. Oh, and I need to capitalize that correctly. Cool, so it starts out as false. Choose a random position, set the starfish to that position, and then whenever it overlaps, we'll keep repeating and trying out new random positions for that starfish. Right? It might be the case that on our first pass through that there is no overlap and this remains false. Right? If this condition is never triggered, then that starfish is in an okay position. All right, so let's go ahead and give this another run. Hopefully this time around, the starfish will not overlap the rocks. And hopefully my program doesn't hang. You know what it was? After thinking about this for a minute, the problem is when rock overlap becomes true, if it overlaps once, then it'll keep on repeating this forever. We have to be optimistic at the beginning and set rock overlap to false. Right? Innocent until proven guilty. There is no overlap until we can actually find overlap. So maybe I'll just rewrite the code like so. And hopefully this time we'll see our desired effect. Remember, the goal is no starfish overlapping any rocks. Yeah, that looks pretty good. Although, we could have gotten lucky in theory. So to do a very serious test, let's add 200 starfish. And hopefully we'll see little clusters of starfish around, but not overlapping any of those rocks. Hey, sure enough, you can kind of see how those starfish have made room for those rocks. Right? And the number of rocks is small enough that I'm pretty sure they're not going to be able to set up an impenetrable wall that I can't get the turtle past. I mean, I guess in theory it is possible even with 3 rocks to get a game in which you can't have a way to win. Like for instance, maybe the 3 rocks form a small triangle and there is a starfish lodged in between them. So again, randomly generated games are tricky, something to keep in mind. So the last thing I'd like to do, which is kind of fun, is show you what happens if we make one small change in the code. And this could lend itself to a really cool mechanic. Right now, overlap is prevented between the turtle and the rock in this part of the update function. Right? Turtle prevent overlap rock. Now, prevent overlap is not a symmetric function. It makes a big difference if the turtle is being adjusted or if the rock is being adjusted. To demonstrate, let me go ahead and switch those around and let's see what happens. Right, at the beginning, the setup should look the same. Right? We'll still have our randomly scattered starfish. We'll have a couple of rocks. And I can move around. What happens when I move up next to a rock? I can push the rock around. Right? The idea here is that the rock is being adjusted whenever there's overlap between the turtle and the starfish. And so I can move these things around. I'm not sure what kind of a game you'll want to make with that, but that remains a possibility. So already we're having a lot more fun with Starfish Collector as we progress in our quest to get to Starfish Collector 2. So that's all we'll say about simulating solid objects for now. In the next video, we'll start talking about improving the graphics. Thanks for watching.